All right, I think we left off at writing a test case for parser. So let's get started. The test case follows the same principle as the test for our lexer and pretty much every other unit test we are going to write. We provide monkey source codes as input and then set expectation on what we want the AST that's produced by the parser to look like. We do this by checking as many fields of the AST nodes as possible to make sure that nothing is missing. I found that a parser is the breeding ground for off by one bugs, and the more tests and assertions it has, the better. I choose not to mock or stub out the lexer and provide source code as input instead of tokens, since that makes the test much more readable and understandable. Oh, okay, that's why he passed in the lexer into the parser. Okay. Of course, there's the problem of bugs in the lexer blowing up tests for the parser and generating unneeded noise, but I deem the risk too minimal, especially judged against the advantages of using readable source code as input. There are two noteworthy things about this test case. The first one is we ignore the value field of the AST let statement. Why don't we check if the integer literal 5, 10 are parsed correctly? The answer is we're going to, but first we need to make sure that the parsing of let statement works and ignore the value. Okay. The second one is the helper function test let statement. It might seem over engineering to use a separate function, but we're going to need this function soon enough. And then it's going to make our test cases a lot more readable than lines and lines of type conversions strewn about. But as an aside, we won't look at all the parser tests in this chapter, since they are just too long. But the code provided with the book contains all of them. Okay. Time to flesh out the parse program. Parse program. Okay. AST program. Program statements. Next token program parse statement. Doesn't this look similar to parse program pseudocode function we saw earlier? See, I told you, and what it does is the same too. The first thing parse program does is construct the root node of the AST as an AST program. It then iterates over every token in the input until it encounters an token EOF token. It does this repeatedly by calling next token, which advances both p.currentToken and p.peakToken. Every iteration it calls a parse statement whose job is to parse a statement. If parse statement returns something other than nil, a statement is its return value is added to the statement slice of the AST root node. When nothing is left to parse, the AST program root node is returned. Okay. Parse statement. Func p parser parse statements AST statement switch p cur switch p cur token dot type case token dot let return p parse let statement. p.expect p token sign return. Let's just write this. Alright, whatever. We're skipping the expression until we see encounter is semicolon for card is token, not semicolon. P dot next token times. Alright, let's just write all this function first. P parser current token is T token type bool. This are just some conditional, just some hyper function. T P parser P token is T token will return P token expect peak T token P token is T P dot next token. Go test. So it worked. All right, let's just see what we wrote. So we wrote the parse program, we create a program, and we create some statements. We iterate through the current token type if it's not end of line, and then we just parse the statement. Parse statement is just a switch statement. All right, let's parse it. So this is just adding to the program statements. And then you just go to the next token. Next token. Okay, so just keep going. Okay, just keep, yeah, it's just put current token as peak token and peak token as next token. That's fine. This is defined. Okay, that is in Lexer. That's fine. Okay, next up is, so it's understand. So it's just iterating through all of the tokens, and what is this? It's returning a statement, right? So it's not nil. Oh, okay. If it's not nil, then it will append. I'm assuming once it is a state, if it is not nil, then this thing will just exit. Okay. Parse statement. So let parse that statement. So it's just setting the AST to token p dot token. So this is let statement if expecting peak, not ident. So let statement is just, let's return now. Statement name. Literal. It's not ident. Statement name. Token, current token, not literal. What's expect peak doing? So if peak token is, oh, okay, it's just doing ident is, okay, so just identifier. How does it know if it is ident token is peak token? token identifier. So if it is identifier, then we know. So pretty much once it's know for sure that it's a statement, so just looping until it's an encounter a semicolon. And if it is, we just return back the statement. That's how it works, it seems like. Let's see the explanation. Let's start with the parser let statement. It's construct an AST let statement node with the token. It's currently sitting on the token let token, then advances the token while making assertion about the next token with calls to expect peak. First, it encounter a token ident token, which it then uses to construct an AST identifier token. Then it expects an equal sign. Finally, it jumps over. Okay, makes sense. So basically, expect peak. It's just checking whether if it's identifier, and then it's just checking if it's assign, and what the rest it's just skipping right now. Okay. The cur token is and expect peak token is methods do not need much of an explanation. They are useful method, blah, blah, blah. Instead of accepting tiny methods, let's talk about expect peak. Expect peak method is one of the assertion function nearly all parsers share. Their primary purpose is to enforce the correctness of the order of the tokens by checking the type of the next token. Our expect peak here checks the type of the peak token and only if the type is correct. Thus, it advances the token by calling next token. As you'll see, this is something a parser does a lot, but what happens if we encounter a token in expect peak that is not of expected type? At the moment, we just return nil, which gets ignored in the parse program, which result in an entirely statement being ignored because of an error in the input silently. You can probably imagine that this makes debugging really tough, and nobody likes tough debugging. We need to add error handling to our parser. Okay. Parser. Oh crap. So we just add error to the struct. So string lexer. What's this? So just printing out list of string, return p errors. Wait, I'm writing the same thing. Func p parser peak error t token, not token type. Message t spring f. Extend TP peak token type p errors. Message. Alright, we gooch. Whoops. What's going on? The parser now has an error field which is just a slice of string. This field gets initialized in new, and the helper function peak error can be used to add an error to errors when type of peak token doesn't match the expectation. With the error methods, we can check if the parser encounter any error. All right. So now so once it's finished parsing the program, we are just printing out the error, pretty much. It seems like. Let's go and parse the text. Test statement. Check parse error. Check parser error. Okay, if life. Okay, this is just a helper method for the test case. So we can do something similar probably in the repel. Message range errors T dot error F parser error Q T not fail. No. Peak. So return true. Now we just do p dot peak error and then just put in the token. This is just going to append it to the parser error message. So the message is just the expected token type. Okay. Makes sense. Okay, let's just test out an error real quick. Okay, let's just remove y. It seems like you can just see has one error. This thing would have 3 errors, seems like. Yep. Alright, we good. Makes sense. Okay, our parser showcases a neat little feature here. It gives us error for each erroneous statement it encounters. It doesn't exit on the first one, potentially saving us the grunt work of rerunning the parsing process again and again to catch all of the syntax error. That's pretty helpful, even with line and column number missing. Parse return statement. Let me just do at the bottom. Return statement struct. Okay. Token. The return. There's nothing about this node that we haven't seen before. It has a field for the initial token and return value field that will contain expression that has to be returned. We will again skip the parsing of the expression and semicolon handling for now. Come back to this later. The statement node and token literal methods are there to fulfill the node and statement interfaces that look identical to the method defined on the AST let statement. Okay, let's write another test case for this. Alright, so what do we run so far? Just put it at the top. Func test return statements t testing t input It's doing. Okay, statement. Okay, that's fine. It's the same thing as the other one. So are we doing the same loop? Oh, is it? It's doing the same loop, right? Alright, let's just write it. For statement. I think go test. All right. Okay. How far? Okay, let's just write this and then we can call it a day. Parser. We're just doing a switch statement on the parse program. Parse statement, I mean. Case token dot return p dot parse return statement. Parse return statement. Fuck p parser. Parse return statement. st dot return statement. All right, seems like a good stopping point. Next up is parsing expression. All right, cool.